ELI5 is 0.999. 1. I would not say this is the foundation of mathematics. And this is not about rounding up, this is just a ways to represent the same quantity. Most people gets confused because they think of the series 0.9, 0.99, 0.999, etc., and how it goes nearer and nearer to 1, but never reaches it. This is not a series of numbers, this is one single number, that has an infinite number of digits. Now, besides the other proofs already posted here, think about what will be the difference between 0.999 and 1. If there is no difference, then they are the same numbers. Is it simply the case of rounding up for convenience, or is there more to it? 0.999 and 1 are exactly the same value, identical and equivalent. People get confused because they think every decimal number must be different, but that's not the case. There are simple proofs. 130.333, so x3 to get 330.999. 1, but the deep reason is that 0.999 has no gap between it and 1. What's the gap between the two? 1 0.999, 0.000, which means are exactly the same value. It's based on the different ways we have of representing numbers. Some things are fractions, some things are decimals, and there are lots of other ways to representing numbers. As many other people have posted, we can easily show that 1313131, but the only way to represent 13 in decimal is 0.33333333 forever. Confused? Here is a Tom Scott video that kinda gets to the same point with a description of floating point. Let's break down what 0.999 is and what the means. The means in nines keep going forever, so 0.999 also means 0.999999999999999999999, and it also means 0.9999999999999999999999999999999, and the nines just keep going. 0.999 doesn't exactly means 1 in math, 0.999 effectively means 1. Effectively meaning you won't find a significant or meaningful difference between 0.999 and 1, making them essentially equal to each other. Let's look at the number 0.9999999. If we multiply that by 10, we see that 10 and 9.999999999. But then, this is the same as 9a and 9 0.9999999. We can subtract a from both sides, and get 9a9 0.9999999. A? But the number in brackets is 0 since this is a. We end up with 9 and 9. We divide by 9 and get a 1. We see that 0.9999999 is in fact just a fancy way of writing 1. Just like 22 or 99. My maths teacher used to flip it around and say that trying to imagine a long string of 9s that gets closer and closer to 1 and eventually gets there is flawed, because infinity is not a finite number and therefore can't be expressed using them. Instead, treat the literal definition of infinity as the place where 0.999, and leave it as that, a concept instead of a number. Could be total nonsense, but it worked for me. I was told to think of an arrow heading towards its target and having the distance traveled using maths to arrive at the point of impact. So, taking the example of an arrow shot from a distance of 100 meters, half the distance 50 meters. Half of 50 meters 25 meters, half of 25 meters 12.5 meters, etc. If you keep repeating that math, it will never actually touch the target and reach 0. Yet we know it does. Does it? It's why we use limits. Consider the function f(x1x), as x goes towards 0 from the positive or negative side, the result would go to or infinity. But because we can't divide by 0, x will never be 0 but will continuously get closer to 0. 0.000000000000001. So we express it as the limit of fx as x goes to 0 for fx1x is plus or minus infinity. The easiest visual solution to it is, let's call x 0.99999. Well, let's multiply it by 10, or shift all the digits left by 1. 10x 9.9999. What happens when you do 10xx? 10xx 9.9999. 0.9999. All the 9s after the decimal point will cancel each other out, so 9x 9. x1. If x 0.99999. From this start in x1, then 0.9999. 1. Here's another way to think about it: name a number that sits between them. Hint: you won't be able to. If two numbers are different, you should always be able to find another number that sits somewhere between them, for example, the average AB2. But there is no such number between 0.9 and 1 since they are the same number. There are tons of demonstrations. The easiest is the algebraic one with the use of fractions. 0,999. 3, 0,333. 0,333. 310,13913. 0,999. 3, 0,333. 3, 131. The other answers are correct as well, but use analytics and real numbers approach. The algebraic one, while not being a proof, is more direct. Everyone knows that 13 equals 0.333. Right? Now multiply that by 3 and you got 3310.999. The reason for that is, that you can't find a single number between 0.999 and 1, therefore it is the same. Imagine a number line where you can zoom in as much as you want, but never been able to find something. No, it's not rounding up. 0.9, 0.11. We all know that. 0.99, 0.011 as well. More generally, the number 0.9999. With a 9's we'll call it 0. 9 and 1, 10 and 1. 0. 9 and 1, 10 and 1. As n gets infinitely large, 1 10 n becomes 0. When n is infinity you have 0. 901. TLDR: infinity be weird. The real math proof isn't ELI5 level, but this can help your mind wrap around it. X200B. 190.11111111. 290.22222222. 390.33333333. 490.44444444. 590.55555555. 690.66666666. 790.77777777. 890.88888888. 990.999999999. 99 is also a 1. 10.90.1. 10.990.01. 10.9990.001. 10.9999999999.00000000001. 10.999. An infinite string of 9's. 0.000. An infinite string of zeros. There is no 1 on the end of the infinite string of zeros, because there is no end. 10.999. 0. 10.999. Not sure there's a way to explain sorry this simply. Some things just can't be dumbed down, especially when you're talking about mathematics related to infinity, since infinity is a concept extremely unintuitive for humans. But I think top comment is a good way to put it in words. There is an actual proof for it. Always remember that these digits are infinitely long. 0.999999. X. 9.999999. 10x. 10x x 9x. 9.999999. 0.999999. 9. 9x 9x. 991. x1. This is why endlessly repeating digits are hard to describe. There is literally no difference between them. Difference is a result of subtraction. 10.999. 0.000. What is 0? Infinite number of zeros. 0. You may be imagining that there should be a 1 somewhere at the end, but there is simply no end. I posted it in the answer just now earlier, but it's one of my favorite proofs. We'll write 0.999 instead of 0.999 repeating, but assume it goes on to infinity. Set in 0.999. Therefore 10 and 9.999. 10 and 9.999 0.999. 9 and 9. And 1. It's not exactly 1, but it's so close to 1 that it doesn't really matter. Kinda like how pi is infinitely large, but NASA only uses 15 decimals in all of their calculations because it's close enough to get them where they need to be. Easy! What's the decimal representation of 13? 0.3333 repeating. 23 is 0.6666 repeating. Add 13 plus 23 and you get 0.9999 repeating. But we already know 33 is 1, so when 0.9999 repeating. I know it's not ELI5, but you can prove it algebraically. Let x 0.999, 1, multiply by 10, 10x 9.999, 2. Subtract 2 from 1, 9x 9. Divide both sides by 9, x1 0.999, is not equal to 1. It gets closer to 1 the further you inspect the numbers but never quite reaches it. So the question in itself is incorrect. 0.999, 0.999, and 1. If they were different numbers, we could do 0.999, 1 2 to get a number that's even closer but still less than 1, and such a number can't exist, because what would it be? I always understood this when I was told. There is no number in between 0.999 and 1, therefore they must be the same. I think it was a Veritasium video. Maybe 3 blue 1 brown. You will never find a gap between 0.999 and 1. If you keep zooming in at the difference between the values, it keeps getting closer to 1. Forever, because 0.9999 is not a number but a limit, the limit of what you get when you subtract 1 10 into 1. That limit is 1, not almost 1. Corollary: how do you express the concept of a number that gets infinitely close to 1, without ever reaching it? A limit of some sort? Simple. 0.9999, x, multiplied by 10, 9.9999910x. Now do an equation to equation 1, and you get 99x. Hands. 1x.